All right, lesson 10.1. We're going to work into the world of ratios and proportions, which in many cases this is review material. So the first section or two of lesson 10, some review information before we move on into new stuff. So our three I can statements in this case, when we get done, we need to be able to write ratios, to find equivalent ratios, and to compare ratios, decide which one is larger than the other, and so on. So those are our three I cans that we need to be able to do when we finish this particular section. So ratio, and one of the things I want you to think of when you hear the term ratio is fraction, okay? And because a ratio in many ways is a fraction, or can be written as a fraction. But then there's a couple other formats. So ratios can be written in three formats. First is fraction, okay, which will probably be the common one that you are used to, 2 to 3, 2 out of 3. Also as a phrase, 2 to 3. Or we can write it separated by a colon, 2 to 3, and that's how it would be read, 2 to 3. But most of you, in this particular case, a ratio, you're going to deal with probably the fraction format. Fractions tend to be most comfortable for most students to work with, just because they've been dealing with fractions for quite a while. So now, we're going to write some basic ratios. 20 students were asked to choose their favorite music category. 8 chose pop, 7 chose hip-hop, 5 chose rock. Write each ratio in all three formats. So we are going to write the ratios in all three formats. In this case, we're going rock to hip-hop. Let me do this. So up here, 8 chose pop. Let's see, 7 chose hip-hop, 5 chose rock. So now when we write this ratio, actually I guess I don't need to highlight, we're going to go rock first, hip-hop second. So how many people chose rock? Well, in that particular case, 5 chose rock. So 5, and I'm going to do it as a fraction first, 5 to hip-hop in this case, 7 chose hip-hop. So 5 to 7. If we write it as a phrase, it's 5 to 7. If we write it with a colon, it's 5, and then your colon, 7. All of these cases read as 5 to 7. Rock to pop and hip-hop. Well, rock, that's easy enough. We've already said is 5. But when we go, in this case, to pop and hip-hop, we're going to add the pop and the hip-hop together. Now, we already know the hip-hop is 7. Pop, in this case, is 8. So we're putting those together. 8 plus 7 is 15. And so in this particular case, 5 to 15, this could be reduced. But in this particular case, I'm going to go ahead and leave it 5 to 15 as a phrase using the word to. And then we also have 5 colon 15. And when we get into the equivalent ratios and things like that, we would reduce this. But in this particular case, for what we're doing, 5 to 15 is fine. All right. Find two ratios that are equivalent to each given ratio. Now, possible step is to multiply or divide the numerator and denominator, that should be a D, and denominator by a common factor. And we do this all the time when we add and subtract fractions, when we have to have common denominators. So in this particular case here, I'm going to do both. In the first case, I'm going to reduce. So if I go ahead and I reduce this fraction, and I know that 6 divides by, and 9 both divide by 3. If I divide by 6 by 3, I get 2. If I divide 9 by 3, I get 3. So 2 to 3, or 2/3, is an equivalent fraction to 6/9, 6 to 9. So that's one possibility. Or, let me go ahead and get rid of this. I could say multiply by 2, which is the common thing that most of you will do. So if let me put a comma here, 6 times 2 would be 12, and 9 times 2 would be 18. So 12 to 18 would be an equivalent ratio. We have to understand as well is that we can do anything to the top and the bottom. Okay, what if I multiply by 3? Okay, well 6 times 3 is 18, and 9 times 3 is 27. All of these are equivalent to 6 to 9. Okay, we only needed to find 2. I found 3. All right, so 51 to 36. Okay, now I have choices in this particular case, depending on what you want to do. I could, let's do the simple one, I could multiply by 2. 51 times 2 is what, 102? And 36 times 2 is 72. And so that would be an equivalent ratio. Okay. Other choices, I could, if I want to, I could divide, let's see, 51 and 36 both divide by 3. Okay, let's see, 3 goes into 5 once with 2 left over. 3 goes into 21 7 times, so 17 if I divide by 3. 3 goes into 3 once. 3 goes into 6 twice. So the ratio 17 to 12 is also an equivalent ratio. Again, so whatever I do to the numerator, I have to do to the denominator, just as if I were adding or subtracting fractions. So however you choose to deal with that is up to you, as long as you do the same to the top and the bottom. All right, so comparing some ratios. So in this case, we want to figure out which one is bigger than the other and so on, or which one is smaller. Honey lemon cough drops come in packages of 30 drops per 10-ounce bag. Cherry cough drops come in packages of 24 drops per 6-ounce bag. Tell which package has the greater ratio of drops to ounces. Okay, drops to ounces. And that is important, by the way, drops to ounces. They're telling us the order here. But first of all, let's do here are your steps. You want to copy these down off to the side somewhere of your paper. So steps for comparing ratios. I would write your ratios as fractions, although you can use the other two formats, and then compare them using common denominators. Okay, because you're comfortable with fractions and common denominators. That's what I'm going to encourage you to do. So, drops to ounces. All right, so let's go ahead and set those up. So let's go back to the beginning. Honey lemon cough drops come in packages of 30 drops per 10-ounce bag. Drops to ounces is telling me 30 drops over 10 ounces. Here, why don't I go ahead and put a little 10 ounces on the bottom. These are my 30 drops. Okay, and these are my honey lemon drops. Okay, then we have cherry cough drops. So cherry, and again, drops to ounces, that's 24 drops to 6-ounce bags. And we want to compare them and figure out which one is bigger than the other and so on. Okay. In this case, I'm going to go ahead and use common denominators. And in this case, I could use 30. I'm going to go ahead and use, just for the sake of, I know that 10 times 6 is 60. I'm going to go ahead and use 60 in this case as a common denominator. Okay. So basically what we're saying is if we took these bags and made them into 60-ounce bags, which one would have more drops? Okay, so now here I would be multiplying by 6. 6 times 3 is 18, and tack on my 0. So in this, if I had a 60-ounce bag here, I'd get 180 drops. Over here, I'm multiplying by 10. 24 times 10 is 240. Okay, so the question, tell which package has the greater ratio of drops to ounces. Well, I have 240 to my 60 here. I only have 180 to my 60 here. Cherry has the higher ratio of drops to ounces. And that's if I use common denominators to compare my values. I could do division. 3 divided by 10, that's 30 divided by 10 is 3. 24 divided by 6 is 4. 4 is bigger than 3, so in this particular case I could have done that as well. Okay. Then we're going to work on, or move into the world of proportions. Now, proportions are an equation that states that two ratios, fractions, are equivalent. Okay, so get that equation or that definition down, and we're going to go ahead and so pause if you need to. I'm going to jump ahead here, hit play, and catch up when you're ready. Okay. Now, to determine whether ratios are in proportion, we're going to do one of three things. One, we can reduce ratios to lowest terms. Two, we could place them into a common denominator format and compare the numerators. Or three, we can use cross products, which is cross multiplication. And if the cross products are equal, our ratios are in proportion, which means that they are equal. So we're going to go ahead and do an example. I'm going to set up a ratio, and we're going to check to see if they are equal or not. So environmental application. On average, each American recycles about 1.4 pounds of trash per day. To see how his family compared, Adam weighed the family's recycling on Earth Day and recorded the results in a table. So over here to the right, we have a table of Adam's family. On the bottom, you'll notice 4 and 7.2 pounds. 4 people, 7.2 pounds. Is Adam's family's recycling in proportion with the U.S. average? Okay, so we have our choices. So let's go ahead, first of all, and set up our ratios. The U.S. average is 1.4 pounds for one person per day. Now, how you choose to set this up is okay view. I'm going to go ahead and go 1.4 over 1 in this case. So this is pounds, LBS, per person. Okay, Adam's family is 7.2 pounds for 4 people. And we want to check to see if these are equal. So we have our 3 choices. One, we could go to common denominators, which in this case would be 4. And so in this case, I could leave this fraction alone. I could multiply the top and the bottom here both by 4, and then compare my numerators if I wanted to. For this particular case, just for the sake of doing it, I am going to use cross products. Okay? So because if these are proportional, if these fractions are equal, the cross products will be equal. Okay? So if I do cross multiplication, the answers to those 2 things will be the same if these are in proportion. So, all right, let me change colors here. So I'm going to cross multiply here, and I just like to do this. This is not, you're probably not going to see this in a textbook or anything like that. It helps me to show my cross multiplication. 7.2 times 1 is 7.2. Okay, so now if I cross multiply the other way, okay, and if you're using a calculator or whatever means you're using, okay, so 1.4 times 4 is 5.6. Okay, these are not equal. Therefore, Adam's family is not in proportion with the average. Now, we could go to the means of the next part of which one is bigger and so on. So, and I'm going to just go down here. If I were to go back, let me change colors again. If I wanted to figure out which one was bigger, I would probably go back and do my common denominators. Again, this one over here is already 7.2 over 4, so I wouldn't have to change that one. 1.4 times 4 for my numerator here would be, oh, we already did it. It's 5.6. So if we wanted to figure out which one was in greater proportion, well, in this particular case, Adam's family, this is the one over here, is in greater proportion, is above the average of Americans. So, all right, so that gets us through our quick little review of proportions and so on, and again, it's a fraction work and things like that. So if you have questions, come see me and obviously show your work.